Wishing you a very good afternoon, everyone. Here, so I'm very excited to see the model they have presented here. You can see a lot of gadgets they have used here. So I like them to introduce the gadget that have used here and to make these models successful. Right? Is it working or not? Huh? So it's going to be very interesting. So I'm very excited to know about this. So first of all, let's start with the introduction. Okay. So let me stand aside. You take the lead of this. Come on.
Good afternoon, everyone. So today we are here with our presentation on the topic Ohm's law. And for the Ohm's law, the things that we require are the battery eliminator. Then we need two meters, one to measure the voltage and one to measure the current passing. So to measure the voltage, we need the voltmeter. For the current, we need the ammeter, and we have a plug key here, and we have a rheostat here. So the work of the rheostat is that it adjusts the resistance. Then the work of these two are to measure the voltage and the current that is passing through this, and the circuit diagram and the explanation of the circuit diagram will be given by Bhaktya.
Good afternoon, everyone. First of all, I'd like to thank Sir Amit for giving me this opportunity, and I am here to explain you about the circuit diagram of Ohm's law. So first of all, I like to introduce the objects that are used. This is the battery eliminator, this is ammeter, this is voltmeter, this is the resistance or resistor, this is the rheostat, and this is the key or switch. So from the positive terminal of the battery eliminator, it is connected through to the.
You can show here better, na? You can show here also, it will better, na? Okay. Now so. Okay.
So from the positive terminal of the battery, it is connected to the positive terminal of the ammeter through a copper wire. From the negative terminal of the ammeter, it is connected with the resistor to the positive terminal of the voltmeter. From the negative terminal of the voltmeter, it is connected to the rheostat through the resistor, and from the resistor, it is connected to the switch. From the switch, it is connected to the negative terminal of the battery.
Okay, good.
And now further display will be given by Vivek.
Good afternoon, everyone. So today I came over here to explain the connection that we have done. So let's start. So as you can see, the positive terminal of the battery emitter is connected with the negative terminal of the emitter, and the positive terminal of the emitter is connected with the rheostat, and the another point of the rheostat is connected with the switch, and then the negative terminal of the voltmeter is connected with the another point of the potential difference. So our topic is Ohm's law, and the explanation is to.
So hello everyone. So basically now I am going to state that what is the main Ohm's law. So Ohm's law states that the current across a conductor is directly proportional to the voltage of this across the wires. So now let us show practically how it works. So as you can see, the voltage here is 0. So when this battery is off, both the meters are at 0, as you can see. So when I turn it on at 6 volts, the voltage across this connection is 0.2 volts. Also the current is 0.1 amperes. So now as we moved the resistance, as you can see, the voltage also increases as well as the current also increases. Take the readings of the both the devices. So see, first the voltage is 0.2 volts. So 0.2 volts, and the current is 0.1 ampere. 0.1 amperes. So now as we change the resistance, the current moved to 0.2 volt amperes, and the voltage changed to 0.4 volt. Again, when we change the resistance, the current changed to 0.4 amperes, and voltage changed to 0.5 volts. So as we can see, so at first the voltage was 0.2 volts and the current was 0.1 ampere. As we change the resistance, the current increases as well as the voltage also increases. This means that voltage is directly proportional to current. Here V states potential difference and I states current. So when we take the perfect readings and make a graph, it will be always a linear graph like this. This is the graph. This is called the graph for Ohm's law. So here this horizontal line, that is the x-axis, represents the voltage, and this vertical line, that is y-axis, represents the current. So the graph of the Ohm's law is always linear in structure, that is both will increase if one increases. So Ohm's law is also useful to finding out the resistance, that is across the wires.
This way, right?
Yes.
Okay. What is the formula?
It is, see, we know voltage V is always proportional to I. To make both the equal, the V will be equal to I, and we will take a constant term, that is R, and this R is known as resistance. So when we divide voltage by the current, we find that resistance of the conductor. So that is, so here we find the mean resistance of the conductor. So let's focus here. So the voltage here is to 0.2 and the current is 0.1 amperes. So when we divide, it will be 2 ohm. The SI unit of resistance is ohm. And for the second case, the voltage is 0.4 volts and the current is 0.2 amperes. So here will be the 2 ohm. And now in this next case, it is 0.5 volts by 0.4 amperes. So it will be just, so here the resistance is 1.25. Let's find the mean resistance, that will be, we will add all the resistances and divide that by the total number of resistance. So here it's 2 plus 2 plus 1.25 by 3. It will be 2 plus 2 4 5.25 5, it will be 1.05 ohm average.
Clef. Very good. Very good.